Good morning, DevConf. How are you doing this morning? Hands up anybody who had one beer too many at the party last night. You're not allowed to put two hands up. That's cheating. Good morning. I'm Dylan Beattie, and I want to talk to you this morning about something called the cost of code. So this is me. I'm the CTO at Skills Matter in London, a tech conference and training company. I'm a Microsoft MVP with the Visual Studio and developer tools. I run the .NET user group in London, and I invented a programming language called Rockstar, which some of you may have heard about in the talk today. And, you know, I'm a nerd. I love technology. I've been playing with gadgets and computers and software pretty much my entire life. And it is amazing the extent to which the world we live in runs on software. You know, almost every single thing that I do. When I listen to music now, it's on Spotify. I talk to friends on Facebook, movies, Netflix. I use Google for playing, you know, recipes in the kitchen when I'm cooking and stuff. I can't even go for a walk outside without getting my phone out to look at the weather report to see, you know, is it sunny, is it going to rain? And, you know, this is amazing. It's brilliant. And I don't want anyone to come away from this talk thinking, oh, Dylan says software and technology are bad, because they're not, you know. They're amazing. I love living in a world where all of these things are possible, but the extent to which we rely on software, the extent to which our world runs on software, it raises some questions, you know, questions that I don't think as an industry we are doing enough to talk about. And so I want to talk a little bit about this idea, what does code actually cost? And I'm going to start off at one extreme by going back to the 1980s and games consoles and Super Mario, the original Super Mario Brothers game. Now, the reason I put Super Mario in, I was looking for an example of code that kind of didn't cost anything, code that was just pure profit, effectively. Now, Super Mario was written by a team of 8 people. It took them about a year. It was released in 1985, and it came out on a cartridge, and it sold something like 40 million copies in the United States at about $25 each. Now, once they had written Super Mario, it was finished. There were no updates, there were no vulnerabilities, there were no service packs or maintenance or hosting costs or anything. That was done. Literally, Nintendo owned the code, and every time somebody obtained a copy of that code, Nintendo made $25. So 40 million copies, $25, you know, that's a lot of money they made out of this code base. And one of the reasons why it's possible, of course, is that they controlled the entire platform. They controlled the hardware, they controlled the software, and nothing was online. Nothing was getting attacked. You know, there were no libraries and dependencies and vulnerabilities, and all the code in that game was basically written by hand. Now, by coincidence, Super Mario was about the same size code base as the CSS on Facebook's homepage. And Facebook get about 4 billion hits a day or something. So if Facebook charged as much for code as Nintendo, they'd make $36 million a day off CSS. Now, you know, even that, Super Mario there, yeah, it was massively profitable. And once it was done, it was pure fraud. But there was an upfront cost to it. They had to pay people to go in and, you know, create the first iteration of that system. Let's dig a little deeper. What if software was actually free? Now, free software is older than paid software. The first kind of computer systems and the whole concept of computer programming dates from the very late 1950s to the 1960s. The idea of selling software didn't come around until the 1970s, about 10, 15 years later. And that's because in the earliest days of the computer industry, very few people had access to machines. There's no point selling a program because nobody had anything to run it on. Most computers were built and managed by the people who programmed them, the engineers and the scientists working in the labs and the software companies. It wasn't, like I said, until the sort of 1970s when companies started going, hey, we've got this program here, we can sell it, we can sell this for money. And the free software movement and the Free Software Foundation was kind of a backlash to that. It was them going, no, we don't think you should be able to sell software. We think software should be free. And the question is, you know, when they say free, what are they talking about? There is this famous idea, you know, there is something can be free as in free beer, or something can be free as in free speech. Now, the Free Software Foundation and the open source movement and a lot of the sort of the more political elements of the free software movement are about free as in speech, freedom from restrictions, the freedom to copy software, the freedom to share it and modify the code and all these kinds of things. But do you ever have that thing where you're at work and there's this tool that you want to use and you go to your boss and say, hey, can we use this? And your boss says, what does it cost? And you say, well, it's free as in speech. And your boss goes, I don't care. How much does it cost? What's the cost in money? And that's when it's nice to be able to say, it's free, doesn't cost anything. You know, £0, £0, €0, zero zloty, whatever. Now, free beer sounds like a good idea, right? You ever been to a wedding that turned into a fist fight because there was free beer? Like, let's just say we're going to give beer out to everybody for free all the time. And we're going to have, you know, there will be consequences to that kind of decision. There's going to be health risks. There's going to be alcoholism. There's going to be underage drinking. Maybe giving away free beer is not the best analogy in the world for how we want to talk about software. You know, maybe we're asking the wrong questions here. Now, like a lot of developers, I kind of got my start in software by taking free software, like WordPress and PHP and this kind of stuff, and setting it up and installing it and building little websites for clients. And so, you know, I'd do a job and I would get paid money for free software. And this was brilliant, you know, it's like, it's amazing. And then, you know, you do a job and you go off for a couple of months and you forget all about it. And then one day you get the message and your client is saying, hey, it's Bob, we got an urgent problem with the website, call me ASAP. And you go, oh crap, what's happening now? And you go and have a look and sure enough, there it is. It's something bad has happened. Someone's installed a plugin. And so, you know, you go back to Bob and you're like, well, no, come on, Bob, this is free software. You can fix it. And Bob said, it isn't free. I paid you money. I paid you £5,000 for this. You fix it. And you're like, yeah, but it's free as in you have the right to go in and extend and modify the source code. And Bob says, I don't care. I paid you. You fix it. So the software is free, but actually it comes with a cost. It has a maintenance cost. You have responsibilities. You are, you know, even after you've finished and delivered and shipped that project, as the person who created it, you're kind of responsible for anything that happens for as long as that software is in production. We don't really have a way around this. And I think maybe we need to start thinking about another kind of freedom when we talk about the code that we're creating and the systems that we're pushing, you know. Free as in speech, brilliant. Let's not restrict people's right to use and modify the software that works for them. Free as in beer, great. Let's not let finance be a barrier to entry. But you ever have one of those things where someone's like, what are you doing this weekend? And you're like, nothing. I have a free weekend. I'm not worrying about anything. I'm going to go to the beach. I'm going to ride bikes. I want software to be free as in weekend as well. Software you can trust. Software that you do not have to worry about what it is that it's doing. Now, I was playing around recently. I inherited a code base that was built with React. And I've not ever worked with React before. So I had a couple of days to sort of play around and get a feel for it. And I went online, I did some digging. And, you know, the reactjs.org, it has this page about recommended tool chains. And it says here, if you're learning React or creating a new single-page app, use Create React App. I think, all right, that looks pretty good. So I fired it up, opened a console, and I went, hey, let's create a React app. And I ran it. And it went, oh, look, things. We're installing stuff for you. Look at that. And there's this progress bar. I'm thinking, this all looks very exciting. And it's building packages. And I went into my React app. Now, there's this thing, CLOC, count lines of code. It's a tool I often use to kind of get a feeling for what I've inherited when I pick up a new code base. Now, I've just run that one command. And I'm counting the lines of code that are now my responsibility because they're my project on my machine. 1.5 million. 1,568,000 is 6 lines of Lisp and 2 lines of MS-DOS batch files. This is my problem now. You know, I've run Create React App, and suddenly there are 1.5 million lines of code on my machine that weren't there 30 seconds ago that I am, in some sense, responsible for. Understanding it, knowing what it does, are there security vulnerabilities? Now, I didn't write this code. I don't understand it. I don't know where it came from. I just know that I typed this command that the internet told me to type, and now I have this. And so I went on Twitter, because I like winding people up sometimes. And I put this thing out, and I said, before you even open a text editor, your project contains 1.5 million lines of code. contributed by volunteers and enthusiasts, no formal review or release process. This is normal in modern web development. And this got, quite an enthusiastic response. And what was really interesting is that half of the people who replied to it were going, yes, I agree with you. This is amazing and fantastic. What a brilliant observation. And the other half were going, yes, I agree with you. This is horrible and a dreadful idea, and we should never have done it. I'm like, well, pick a side. Is this good or not? And there was actually some interesting conversation. So Dan Abramov, who's one of the React team, I got into a chat with him. He's like, okay, when you do that, what you're actually doing, that's not just the project. You're installing the entire tool chain. You're installing the build tools and the compilation tools and all of the tooling that's necessary to work with that React app. And actually, even if you build a React app, there's still a relatively small amount of code involved with it. But, it is almost impossible now to build software without accepting these dependencies where you just kind of have to trust that the people who do them know what they're doing. It's like this is modern software development. This is your code over here. And your code isn't going to get anywhere unless you can use Entity Framework, which runs on top of System.Link, which runs on top of .NET Core. There's this chain of trust, and this is Web Forms over here being a jerk. This is how it works now. We cannot get away with it. Now, you could say, no, this is it. New information security policy. No. NuGet not allowed. We are not using any package managers. Now, there are organizations, defense, aerospace, where it is actually so important to get everything right that they do have policies saying you don't install packages. If you need to add code to the system, the code will be reviewed, whether you wrote it or you bought it or you downloaded it. Everything gets reviewed, everything gets audited, everything goes through. But this is an incredibly expensive way to build software. If somebody comes to you and says, can you build me a website? And you say, sure, but we don't use any packages. We're going to roll everything by hand. It's going to take about 6 months to get to Hello World. They're going to go, nah, you're all right. And they're going to go across the street and find somebody who does it with Angular, and it's finished by Friday afternoon, Now, there is this saying in open source, given enough eyeballs, all bugs are shallow. It's called Linus's law. It's actually Eric Raymond was the person who named the law after Linus Torvalds. And, the idea here is that if open source software is popular enough, you get so many people looking at it that they are going to find the bugs in that system. And it's a nice idea. But I have a corollary to this. This is my law. Given enough shiny things, all eyeballs are distracted. There is so much going on in modern software and technology, and just the world we live in. This idea that if you just publish your source code, the world will eventually flesh out all the bugs in it. Yeah, there's kind of some truth to that, but the key word there is eventually. Now, 2014, news broke about a vulnerability. Anyone tell me what this was called? Heartbleed. And Heartbleed was a big deal. Heartbleed was a vulnerability in OpenSSL, the fundamental software that secures your connection to the web servers that you are using to read your email. You're using to enter your bank details, to make purchases, all kinds of things. And Heartbleed, they did a fantastic job of managing the disclosure. There was a task force, Microsoft, Google, Apple, Amazon, all kind of swarmed on this. There was a patch ready and in place when the news of the vulnerability broke. The other thing they did that I thought was really clever that no one had done before is they gave it a name. It wasn't CVE 2014-12345. They said it's Heartbleed. And that meant it made it on the news because newsreaders could go, the Heartbleed security vulnerability. And for the first time in history, nerds like us got to work the next day, and our boss was already there going, what's this thing with Heartbleed? Are we fixed? And I love that. It's so nice to have the media actually putting the onus on business people to come to the technology people and go fix the InfoSec problems, because normally that's the other way around. But, the thing about Heartbleed is it was a big deal, and a lot of very smart, very capable people with their employer support were put on fixing it. This is important. Now, the problem with that is we don't know how much data got leaked in the meantime. This vulnerability was in the wild for a couple of years. So somebody might be sitting out there on a massive stash of Gmail transcripts that they've just got quietly tucked away in case they need them for something. We don't know. We have no idea how much information was leaked or who controls that information now. The bug is fixed. OpenSSL is solid again now. But it's raised this unknown question. What happened to all that data that's out there? Now, the thing with, like I said, Heartbleed was a big deal. Lots of people cared about getting it fixed because it was really important. But that's not always the case. I want to talk about something called the open source entitlement complex. Now, there is not a week that goes by without I see a conversation on GitHub or Twitter or something where somebody has got an open source project. Now, a lot of small open source projects are run by small groups of people. 1, 2, 3 people who they built something useful and then they decided to share it with the world. And people come back to those project maintainers and they are like, I found a bug in your software. And the maintainer goes, all right, yeah, that's a bug, but actually we've got more important things to do. Or somebody just comes back and says, your project is crap. I don't like how it works. It's not right. Fix it for me. And a lot of times, open source people are like, no, you have no right to demand that. We gave away something we created for free, and now the internet is coming back and going, your software doesn't work. It's free. I don't care. You fix it. This is terrible. You're an awful human being. And people burn out. People abandon their entire opens. They're just like, I cannot handle the hostility anymore from the people I'm sharing my work with for free. Now, there is this sort of idea, this myth that open source software is fine because if you find bugs, the community is going to fix them. No, if you're relying on open source software in your organization, have a plan. What do you do if you find a bug in one of your open source libraries and you can't get it fixed? Do you have budget? Do you have a process for going to the maintainer and saying, we found this bug, we'd like to pay you €1,000 to fix it? Do you have somebody on staff on your team who you could say, can you please fix this bug and contribute the patch back to that community? Because just expecting that the free software is magically going to fix itself leads to this sense of entitlement, and when that doesn't happen, people get upset and people get angry and the whole thing becomes very, very negative. Now, the alternative, of course, is, well, we're not using any open source software. It's not supported. We're only going to use commercial software. We're going to use paid software because that comes with a warranty, right? Anyone ever been in like a vendor relationship where you hired a company to write you some code, and they did, and then the code went wrong, and you realize that although the company's still there, all the people who understood your code base have left now. And so basically some junior graduate developer has just been given 150,000 lines of your code and told to fix it. Now that's not really, sure they're going to try and fix it, but it doesn't give you the sort of quality and continuity that you really need if you're delivering these mission critical services. If that software is part of your problem and part of your solution, your platform, then it is your responsibility. You're the one who needs to understand the costs, the risks, all these kinds of things. And it's not just that there can be technical problems and system crashes and security faults. Software can blow up in all kinds of weird and unexpected ways. There was an incident in the UK last year. A woman called Nikki, who is a doctor from Leicestershire, was trying to apply for a Barclaycard credit card on the website, and she'd gone through and she had filled in doctor and then selected her gender as female, and when she clicked submit, it said, sorry, your gender does not match the title you provided. Please check and try again. And so Nikki went on Twitter and goes, hey, Barclaycard, it's 2019. How come I can't be both female and a doctor? And this, it made the newspapers. It got like 25,000 tweets and stuff. It was huge. It had a massive impact. It was a big PR problem for Barclaycard. Now, Barclaycard are not saying women can't be doctors. Barclaycard just haven't tested their JavaScript properly. They've got a compound validation rule that some developer put in for a requirement without ever thinking that this was going to turn into a massive PR disaster with accusations of sexism and misogyny, right? But that code is part of their stack. They grabbed a JavaScript validation library from somewhere, and they didn't really think about what was going to happen if that went wrong. Now, let's imagine they had. Let's imagine that the team behind that, they were all rockstar developers who never make any mistakes, ever. Perfect, 100% bug-free code. 100% tests, 100% monitoring, absolutely flawless. And so you ship that code into production, and then you're like, all right, thank you, everyone, you're all fired. The code is perfect. And then you wait. And then you read about Meltdown and Spectre, and you think, oh, crap, There are dependencies in our systems that we cannot control. There are dependencies that go way deeper than anything we have control over as developers. Meltdown and Spectre, this is January 2018. Intel went public about the fact there was basically a fundamental vulnerability in every computer ever built that could leak information and data to parallel processors and stuff. Every operating system needed patching. There were a couple of devices which were immune to this. I think AMD processors didn't have it. But basically, one of the optimization techniques that was baked into almost all modern microprocessors was vulnerable. And the only way around it, they couldn't fix it because the vulnerability exists in hardware. So the only way to fix it was to patch it. To patch your software and say, that amazing thing that we put in our CPUs to make them go faster, please don't use that anymore because there's a problem with it. And this meant these patches slowed things down. Leslie Culbertson, who was the information security chief at Intel, she said, if enabled, we've observed a performance impact of 2 to 8%. So you've got a choice. Do you want your computer to be fast or do you want it to be secure? Because if you patch it, it's going to go slower. And if you're using, AWS or Google Cloud or any of these things, your bill is going to go up because suddenly you can't process as many requests for the same amount of money that you were spending last month. Now, the solution, if you want to be fast and secure, is you need to go out and get a new computer, right? Now, if you're running in the cloud, this is easy. You just right-click new computer, you wait 30 seconds, and bang, there it is, done. And it's all somebody else's problem, and it's managed. If you're still running on-premise hardware, you need to order it from Dell and get it out of the box and put it in the rack and all this kind of stuff. But we kind of accept that we replace computers a lot. If you buy a computer in most countries, the government and the tax people are like, yeah, well, a computer's only good for 5 years. So every year you get to deduct 1/5 of the cost from your business accounts, and then after 5 years, you throw the computer away and you go in and you buy another one. And with mobile phones, it's even worse, because the mobile phone industry has somehow managed to get everyone into this idea that you need a new phone every 2 years, otherwise you're a loser, right? And so you get 18 months into your contract, you start getting those messages. Hey, you might be eligible for an early upgrade. And you're like, ooh, early upgrade. This phone is 18 months old. It must be rubbish. Let me go and get another one. And it's all baked into the pricing model, and it's baked into the way the mobile phone contract system works and everything. And, there is a cost to this. This stuff is not free. I have an iPad 2 at home, one of these. And, it is fine, and it works, but it's kind of useless, because it won't run any of the recent operating systems. And so it has to run old versions of iOS. And those old versions of iOS will only run old versions of apps. And most of those old apps don't work because the APIs that they rely on have been shut down. They're not online anymore. So, there's nothing wrong with this thing. It's just not useful anymore. It's sat at home in a drawer, along with my iPhone 3 and my iPhone 4 and my iPhone 5. And there is this crazy upgrade cycle that we get locked into. Now, a modern smartphone is an absolute miracle of engineering. Like, you have no idea until you start digging into it how clever the engineering that goes into these things is. The lens in your camera, in your phone, in your pocket, is made of a tiny sliver of sapphire that's been grown in a laboratory to be exactly the right shape. There are neodymium rare earth magnets. There are quantum floating gate semiconductors, billions of them, like unbelievably advanced technology that we've got really, really good at manufacturing. But the problem with these kinds of really sophisticated devices is they need special materials to work. You cannot just make a phone out of steel, because steel does not have the right properties. You can't make a screen out of steel. You can't make a lens out of steel. There are about 80 elements on the periodic table which are kind of stable at room temperature. They're not liquid, they're not gas, and they're not radioactive. And your phone contains about 60 of them. And I want to talk about just one of those elements, a thing called neodymium. Neodymium is used to make magnets. Neodymium is really, really good at making magnets. This is what neodymium magnets look like if you do daft stuff with them. Now that's some special metal, right? The magnets in your phone, there's one in the speaker, there's one in the microphone, there's one in the motor that gives you the vibration when you have those ringtones and things. And neodymium is difficult stuff to get hold of. Most of the neodymium that we use in the electronics industry comes from China. First, you've got to dig it up. Now, the ore that they dig out of the ground, this is a Chinese neodymium mine, the ore they dig out of the ground is about 5% of neodymium and the other minerals that are used in electronics. The rest of it is mud, sludge, and uranium, which is radioactive. So you dig a kilo of this stuff out of the ground, and then you refine it. And refining that kilo takes about 2 Olympic swimming pools worth of water and lots of electricity. And when you're finished, the water is now toxic. You've got to get rid of that somewhere. The electricity has been generated from somewhere, burning coal, burning oil, we don't know. And you're left with about 5 grams of neodymium and other useful stuff, and about a kilo of toxic radioactive sludge. And the only thing we know how to do with that is bury it, because we have no way of making it clean. We can't use it for anything. So we put it in barrels, and we stick it in the ground, and we put a sign up saying, do not dig here, bad things will happen. And we kind of hope that, future generations will still be able to read those warning signs. And that is just one of the metals that's used to manufacture modern smartphones. Cerium, similar process. It's the stuff that's used to polish the glass on your phone screens. The circuit boards contain capacitors with an element called tantalum in them. Tantalum comes from coltan. Most of the coltan in the world comes from countries in Africa, which are not very politically stable. And the conditions that exist in the mines where people extract this stuff, are absolutely terrible. Lithium. Lithium is used in cell phone batteries. Lithium is incredibly good at storing energy. Now, I don't know if anyone remember the Samsung Galaxy Note, which had this unfortunate tendency of releasing all of its energy in one go. Technical term, I think, is explode, and you're not allowed to take them on aeroplanes anymore. Lithium is really, really good at storing energy. Lithium is expensive. Lithium is toxic. Lithium is difficult to come by. There's about a gram of lithium in most modern smartphones in the battery, all right? Now, this is a Gartner chart about the sales of Android phones around the world. Now, there are about 8 billion total Android devices been shipped. Now, Google publishes stats on how many Android devices are still online. So 8 billion smartphones, 6 billion of those smartphones are Android. Google says that there are 2 billion Android devices still active, which means there are 4 billion Android phones and tablets out there somewhere that got manufactured, sold, used, and then lost or put in a drawer somewhere. Now, you take 1 gram of lithium, it's not very much, but you multiply that by the 4 billion missing Android smartphones that we don't know where they've got, and it weighs as much as the Eiffel Tower. That's how much lithium is just kind of floating around somewhere. Now, you think about these kind of stats, and then you think about this drive to replace your phone every 2 years and everything, and you do start thinking, what is the actual real cost of this constant upgrade cycle? Now, one of the things that I enjoy about being able to, do talks like this is that they often inspire conversations. And the last time I did this talk, someone came up to me afterwards and said, have you heard about the Fairphone? I was like, what's the Fairphone? And there is a company out there right now who are trying to do something about this. This is Fairphone. It ships this November. It's an Android handset that is modular. You can take it apart. You can replace parts. You can upgrade bits of it. And it comes with basically a 5-year supported life cycle. This company, they're based out of Amsterdam, and they are consciously saying, we want to sell you a phone that is going to last for 5 years. And we're going to support the operating system for 5 years, and you can take it apart and you can repair it yourself. So if there's a problem with the battery, you recycle the old one and you can put in a new one. Now, I love this. I think this is a brilliant idea, and I'm going to order one of these and see if it's any good, because I really want to support the kind of stuff they're doing. And there is hope. Fairphone is one example. A lot of places across Europe and the United States now, there are laws coming in about how you dispose of old electronics. Now, one of the really fascinating things about this is there is a literal gold mine in discarded electronics. If you take a kilo of raw ore that you've dug out of a gold mine in South Africa, and you take a kilo of old iPhones, there's more gold in the iPhones than there is in the gold ore. And so it actually makes economic sense to recycle electronics to extract these minerals back. And so industries are now starting to grow up that are doing this. They take discarded electronics and they extract as much of those, rare earth metals and gold and all those things as they can. But, we still have this upgrade cycle. This is 10 years worth of Apple iPhone devices. And, just imagine we said, stop, we're going to have this phone going to last 5 years. The operating system is going to last 5 years. We're not going to move any APIs. We'll fix security holes, but we're going to give you a stable target. And developers, instead of playing catch-up all the time and having to learn the latest APIs and the latest standards, the latest protocols, for the first time since probably the 1980s, you'd actually have dev teams who understand fundamentally all the capabilities of a specific device. Just like back when they were building Super Mario for Nintendo. We could actually get a fixed target, and we could get really, really good at it. Now, imagine if one phone, let's take that entire supply chain. We've got the chemical workers in China, we've got the people in Africa digging coltan out of the ground. Imagine we paid all those people like a reasonable living wage. How much do you think the phone would cost? And if an iPhone cost 15,000 euros, how often do you think people would go around upgrading them, It's not likely to happen overnight, but it's interesting to ask the question. So we've looked at the cost of code that runs right. We've looked at the cost of the devices that are necessary to run that code. What I want to talk about now, what about code that it's written, it's reviewed, it's tested, it does everything right, effectively, and it still causes bad things to happen? Let's talk about Volkswagen. Now, a few months ago, 5 Volkswagen executives were sentenced in a criminal court in Germany for fraud, misleading people, all sorts of criminal charges were brought against them. And this all stems from an incident with some code. There's about 600,000 cars in the US and millions more, we don't know exactly how many, but it's a lot, that are running all over the world, that are running a particular Volkswagen engine with an electronic engine control system which has bespoke software on it. And at some point, round about 2008, 2009, somebody at Volkswagen had the bright idea, hey, what if we hack the software so that when it's running in the emissions testing laboratory, it does one thing, and then when you get your car out onto the road, it does something different. And for some reason, everybody thought this was a good idea, and they went ahead and they did it. Now, emissions testing is there because cars emit pollution that kills people. And that's bad, right? We kind of agree on that? And so the idea of saying, let's have this car so that when they're testing it, it all looks nice and clean, but then when you get it out on the street, it can pump out loads of pollutants because we don't really care what's happening with that. I kind of find that a little bit indefensible. Now, there is a very, very interesting analysis of this that was published in the IEEE Symposium in 2017. It's how they did it, an analysis of emission defeat devices in modern automobiles. It's basically a team of researchers who reverse engineered the firmware that was running on those Volkswagen cars. And what they found is there is a variable, like literally a Boolean flag in the code that tells the car whether it is supposed to be in an emissions testing laboratory or out on the public highway. Now, this is the kind of thing, if I went to work for Volkswagen, I was working on this code, and, probably after a week or two, I'd turn to the person at the next desk, and I'd be like, hey, what's this flag doing? Like, true or false? True is the one where it kills kids, right? And he'd be like, yeah, but don't worry about that. It's orders from high up, Now, Volkswagen have been slapped with something like 20 billion euros in fines as a result of this. There are criminal charges. It's caused irreparable damage to their brand. There was a study published last year that estimates probably 59 deaths. Now, we don't know which 59 people, but if you take the impact of air pollution on people's lives and life expectancy, that line of code in the Volkswagen engine control system has killed 59 people. That's the statistical model. Now, I'm sure the person who wrote it didn't go, yeah, put that in, I'm going to kill a bunch of people, This is the whole, just following orders. We're doing what we were told to do. And, I find it amazing. It's so obvious in that code that something weird is going on, and yet nobody kind of really spoke up about it. Now, this is one of those kind of weird things. I'm sure the person who had the idea to do that did not write the code themselves. And I'm sure that it wasn't just some engineer going, oh, this is a good idea, and then it coasted through all the code review process and everything. But somehow, this happened. And I don't, why did nobody speak up about this? Why did nobody say, I think this might be a bad idea, like, for all kinds of reasons, let's not do this. But, Volkswagen is an example of code where somebody said the requirements were to do a bad thing. And the developers implemented the requirements, it got tested, it got shipped, and then, of course, the rest is history. We know what happened. It's not always that clear-cut. Now, in October last year, Lion Air Flight 610 took off from Jakarta, Indonesia. And 12 minutes into the flight, it crashed. Killed 189 people. There were no survivors. 4 months later, an Ethiopian Airlines flight was taking off from Addis Ababa, crashed 10 minutes into the flight. There were 302 people on board that one. And the common factor in both of these incidents was the type of aircraft. It's a thing called the Boeing 737 MAX. Now, I remember reading the headlines that came out around this. I'm a software nerd. I'm also kind of an aviation nerd. I fly a lot. I've got two uncles who are pilots. I love airports and planes. And I was really interested in kind of watching what was going on here and how this thing unfolded, because I kept seeing this phrase, software problem, cropping up in the discussion about what was going on with the 737 MAX. Now, you need to dig a little bit into the history to understand the context of this. The 737 MAX, Boeing needed a long-range plane. The Airbus, which is Boeing's main competitor, they had a long-range Airbus A320 that was effectively taking a lot of the long-haul routes. And Boeing are like, we need to compete with this. We need a new aeroplane. But there is a big problem with new aeroplanes. To be able to fly passengers on a plane, your pilots need to be qualified. It's something called a type rating. Your pilots need to be qualified to fly that plane. And if you launch a new plane, all those pilots have to go back to training school, and they need to re-qualify. They need to learn the new aircraft, learn all of the systems, qualify, and then they need to do a certain number of hours every year to keep that type rating up to date so that they're allowed to fly with it. So what Boeing wanted to do, on the one hand, they need a new airplane that can fly further than any of their existing ones. But on the other hand, they don't want a new airplane because it's hard selling new airplanes to airlines because they don't want the cost of having to re-qualify all their pilots. So their challenge was, how do we change the 737 enough to get the extra range, but not so much that we need to re-qualify? How can we basically build a new 737, but all the pilots who can fly the old one can just fly the new one using all the training they already have? And so what they did is they put bigger engines on it. Bigger engines, higher airspeed, greater range, it can fly further. And the engines they put on, if you look at it closely, the engines on the 737 MAX 8 are so big, they won't actually fit underneath the wing, so they had to move them forwards and bring them up. And that causes all kinds of headaches. Because what happens if the engines are further forward and further up, is that when you open the throttle, the airplane is going to do this, and it's going to stick its nose up in the air. And so they said, well, that's all right. We'll fix it in software. A thing called EmCasts, the Maneuvering Characteristics Augmentation System. Now, the whole idea with EmCasts, people talk about a software problem. It wasn't a software problem. The software did what the software was built to do. If there was no software, the plane wouldn't have taken off in the first place. They wouldn't have been able to fly it. And what that maneuvering characteristics augmentation system does is it detects when the plane is starting to do this, and it automatically brings the nose back down. And the whole idea is that it does this perfectly and invisibly, and the pilots and the crew don't need to know that this is happening because, hey, it's just a 737, right? Same as the one you've been flying for the last 20 years. We haven't changed anything. Now, those two incidents, what actually happened in both of those cases, and the investigation is still ongoing, but this is what it looks like was happening, is the sensor, which tells the aircraft whether the nose is pitching up or not. There was only a single sensor, and the sensor was faulty. So that sensor sends a signal to the computer, hey, nose is coming up. And that pushes the nose back down again. But of course, the nose isn't coming up. It's a sensor malfunction. So the plane's flying along like this, and the nose goes down. And the pilots try and bring it back up, and the nose goes down again. And this, it looks like, was the common feature in both of those incidents. Now, that software did what it was built to do. It detects the input from a sensor, which is outside the scope of the software system, and it takes the appropriate action to keep the plane airworthy. The sensor failure is kind of the problem, but really what we've got here is just a sort of fundamental misunderstanding at every single level of development and review. People not understanding how software fits into the system of modern aviation. You know, how many sensors are there? What happens if they give conflicting readings? Can we have another one? Who signs off on this? What's the responsibility of the software? Should the crews have been trained on it? There was documentation in the manual, but nobody was required to read it. Is that a problem? And software is just one piece of this incredibly complicated chain of questions and social responsibility that we are still struggling to get right. And one of the problems is that we focus on hypotheticals. You're all clear, you know, the self-driving cars problem about should a self-driving car avoid killing 2 people and steer off if it means killing 1 person over here? What do you optimize for in your code in those kind of situations? Now, those kind of things don't happen very often. I think to date 2 people have been killed by self-driving cars. 2 out of, you know, all of the cars that are out there on the roads. But self-driving cars and autonomous vehicles are going to raise questions which are not hypothetical. They are real questions. The most popular job in the United States right now is truck driver. There are 3.5 million people in the US who make their living, pay their bills by driving trucks. And they drive an 8-hour shift and then they have a rest break. What happens when we replace all those trucks? What happens when 3.5 million Americans are suddenly out of work? Because these things, autonomous trucks, these can drive 24/7. They don't need to take breaks. They just keep going and they keep going and they keep going. What is that going to do to economics, to society, to communities when we destroy 3.5 million jobs overnight by replacing them with machines? We had a little incident in the UK where I'm from a little while ago. We are having the biggest political crisis that the UK has had since World War II as a result of a referendum. It's not a war. Nobody declared war. There wasn't a natural disaster. Somebody consciously decided that they were going to ask everybody this question, and it's 3 years later, and we still have no idea what the hell to do about it. And, you know, a lot of information has come to light since then about organizations like Cambridge Analytica, who were using incredibly well-targeted social media to target specific people with specific advertisements that we suspect were aimed at getting them to vote a particular way. You know, the days when in the UK it used to be that any kind of political advertising was incredibly tightly regulated. All the political parties broadcast anything on television, there are rules. How long can you speak for? What are you allowed to say? Radio is the same. Newspapers are the same. The internet and the web and social media, we have no idea. The lawmaking machine cannot keep up with the rate of change that is going on there. You know, Facebook had this mantra, move fast and break things. And they've broken a lot of things. British democracy, for one thing. And you go on their homepage to this day and it says, create an account. It's free and always will be. And of course, what they mean is you don't have to pay us any money. There are all kinds of costs and questions about a social networking platform run by a private company with 3.5 billion active users. And I don't know how we start answering those questions. But it's really important that we start asking them. But one thing, you know, that is really, really clear is that this idea of the boss, the engineering manager person, who doesn't understand computers, but still, you know, they're in charge. They're making decisions about investments and people's lives and jobs and careers and everything. That's not good enough anymore. Software is part of the system. Software is part of every company, every organization. It is almost impossible to do anything now without relying on computer software as part of that process. We need to help people understand what it is that we do and how we do it and the risks. We need to engage better with them and try and understand the business and the legal and the ethical implications of the code that we're writing. This year, we celebrated the 50th anniversary of Neil Armstrong and Buzz Aldrin walking on the moon. And I think that was worth celebrating. You know, I think it was an astonishing achievement, absolutely brilliant engineering accomplishment by humankind. But, you know, I don't want to celebrate the 12 white guys who went and walked around on the moon. They've been celebrated before. I want to celebrate everybody else. You know, all of the people, the doctors, the engineers, the janitors, the electricians, the people who made it happen. And particularly this person. This is Margaret Hamilton. She was the software engineering lead on the navigation and guidance systems for Apollo. She was the first person to use the term software engineering. And she was an advocate of something called the systems view. You cannot regard software as an afterthought. The software is part of the system. You have to understand how the software interacts with the electronics and the hydraulics and the navigation and the inertial guidance and all these other things. It cannot be treated as we'll do everything over here and then later the software happens somewhere else. You've got to treat the thing holistically. Now, we're running this system. It's a big, complicated system, and we cannot afford to treat software as an afterthought for it. We need to be kind. We need to open up our ideas, open our questions, open our minds, because if we're going to keep running this thing, we need everyone to help us. Thank you. All right, we have a few minutes for questions. Do we have any questions? You need to shout. I can't see anything except really bright light over there. Anybody? No? All right. Thank you very much. Enjoy the rest of the conference. Enjoy the rest of your day. I'll see you next time.